Okay, now you've got a 10th degree polynomial. We're going to use the conjugate method rather than the grouping method, even though it's the same kind of setup. There's a missing power here, and there's a missing power here. So we could do 3 groups of 3 trinomials again, but let's do the conjugate method. So notice this complex root, 1 plus 2i. Well, remember, imaginary roots come in pairs, so the conjugate of 1 plus 2i is 1 minus 2i. And remember, if you had x is equal to 2, when you put it in factored form, you'd write x minus 2. Well, you're going to do the same thing here. You're going to do x minus, whoops, that's supposed to be an x minus. And then what we notice is if we regroup, well, here's an x minus 1, here's an x minus 1. So now you've got an x minus 1 plus 2i, x minus 1 minus 2i. Well, that's a new set of conjugates. That's a difference of squares. Remember, x squared minus y squared is x minus y, x plus y. That's what we've got here. X plus y, x minus y. So we're going to multiply those out. The first times the first, so x minus 1 squared, and then 2i times negative 2i, which is negative 4i squared. And remember, I squared is equal to negative 1. So when we simplify, we're going to square x minus 1 squared, which is x squared minus 2x plus 1, and then subtract 4 times I squared is negative 1, negative times negative is positive. So you've got 1 plus 4, which is 5. So now we can take this trinomial and use it in long division. Now, the one thing you have to remember is where you have those missing terms, the x to the 7th and x to the 3rd. When you do long division, you need to go ahead and put 0x to the 7th, 0x to the 3rd. And now we're going to start with the first term of the divisor and the dividend, and we're going to divide. So 25x to the 10th, divide x squared. When you're dividing powers, subtract exponents. So it becomes 25x to the 8th. So in the x to the 8th column, you put 25x to the 8th, and then we multiply all 3 terms. Well, that gives us the same thing as above. So when you subtract, that whole thing zeroes out. So bring down the 0x to the 7th, the negative, bring down 3 more actual terms that are not 0. I still brought down the 0x to the 7th, but you can ignore it. So you've got negative 41x to the 6th, positive 82x to the 5th, and negative 205x to the 4th. And now we come over here and we divide. Negative 41x to the 6th, divide x squared. And 6 subtract 2 is 4, so negative 41x to the 4th. So right here in the x to the 4th column, and imagine inside here are just a bunch of zeros. We're not going to write them. And when you multiply, that whole thing zeroes out again. And now you bring down these 3. And then you take 16x squared, divide x squared, and that leaves you with 16, and then multiply all 3 terms, and then those cancel. So now you have this trinomial. So we have the original trinomial, where we got the two complex, whoops, that's supposed to be a 1 right there. The two complex factors, so that's 2 of the 10. And now we're going to take this trinomial, and we're going to use a quadratic, but we're going to use the U-substitution. We're going to let x to the 4th equal u. So when you square x to the 4th, you get x to the 8th, and when you square u, you get u squared. And then we're going to rewrite it as 25u squared minus 41u plus 16, and now you've got the quadratic. Here's our a, our b, and our c. So we're going to put that into the quadratic formula. The opposite of negative 41 plus or minus the square root of negative 41 squared minus 4 times a times c all over 2 times a. This simplifies to positive 41, and then negative 41 squared is 1681. Subtract 4 times 25 is 100. 100 times 16 is 1600. 1681 subtract 1600 is, you've got the square root of 81, which is plus or minus 9. And all of that is over 2 times 25, which is 50. Let me get rid of that altogether. And now what you have is 41 plus or minus 9, so 41 subtract 9 over 50, and 41 plus 9 over 50. Well, 41 subtract 9 is 32 over 50, which simplifies, they both have 2 in common, which simplifies to 1625. That's where I got this. And 41 plus 9 is 50 over 50, which is 1. But now we have u. But what did we say u equals? U equals x to the 4th. So, oh, I went ahead and finished it over here. Okay, so x to the 4th. So we've got x to the 4th equals 16/25, and x to the 4th is equal to 1. And then you're going to take the 4th roots. The 4th root looks like this, but another way to think about it is, think about this as x to the 1/2 root raised to the 1/2 root. 1/2 times 1/2 is 1/4. But look at 1/2 means the square root. So it's like the 4th root is the same as taking the square root of the square root. So that's the method I'm going to use here. So we're going to take the 4th roots of both. So I'm going to take the 4th root of x to the 4th and the 4th root, positive and negative 4th roots of 16/25 and positive negative 4th roots of 1. And the first thing we're going to do is we're going to take the inner square root. So this inner square root, well, the square root of x to the 4th is x squared, and now we have the square root of x squared. The inner square root of 16/25 is again positive negative outer square root of 4 over 5. And over here, the inner square root of x to the 4th is, now you've got the outer square root of x squared, the inner square root, so that leaves the outer square root of positive negative square root of 1. And now you're going to take the outer square root. Well, the square root of x squared is x. And then when you take the positive negative root 4/5, well, that's like saying the square root of 4 or square root of 5. Well, that's positive negative 2 over root 5. And then we can't leave a radical in the denominator, so we multiply top and bottom by 5. So we get positive negative 2 root 5 over 5. But remember, this started off as x to the 4th, so there's going to be 4 of these. There's going to be 2 of the positive, 2 of the negative. So we have negative 2 root 5 over 5 with the multiplicity of 2. We have positive 2 root 5 over 5 multiplicity of 2. And then when we take the outer square root over here, we get x, and the square root of 1 is still 1. But remember, this started off being x to the 4th, so that both positive and negative 1 will have a multiplicity of 2. And now you have your 10 roots. We had x is equal to 1 minus 2i and 1 plus 2i. We had x is equal to negative 2 root 5 over 5, and that's a multiplicity of 2. So here's 2 roots, here's 2 roots. And then you have positive 2 root 5 over 5 multiplicity of 2. So there's 2 more roots. And then you had negative 1 multiplicity of 2 and positive 1 multiplicity of 2. So there are, if you add those up, those are your 10 roots. And remember, 2 of these are complex, so if you were to graph this, let's see, we've got negative 1, positive 1, and negative 2 root 5 over 5. I really should do the math of that. Yeah, that's going to be more than, and this is positive. Remember, these are multiplicities. When you have a multiplicity of 2, so if we had x is equal to 2 multiplicity of 2, if you were to graph that, and let's see, and x is equal to, say, 5. So at 2 and at 5, so this would be an x cubed. The graph would come down, and if it's a multiplicity of 2, it doesn't cross the x-axis. So that's what's going to happen here. We've got 10 roots, so this graph is going to, remember, there's going to be 9 turns, 1, 2, 3, 4, 5, 6, 7. Ooh, I guessed. I got lucky. I did that enough times. But when there's a multiplicity of 2, you won't have 9 because they're going to be coupled up. So it's going to look something like this. And then remember, up here somewhere are the 2 other roots, the 2 complex roots. So we've got 2 here, because that was a multiplicity of 2, 2 here, 2 here, 2 here. All right, that's it for this one.